Welcome to a new test and teardown video. This time is another one of those Hameg 8001 series mainframes. I've already released a few videos using these, so I will put a link in the description so you can see about the mainframe. I don't want to repeat all the mainframe things in this video. This video should cover the two plug-in modules, the 8040 triple power supplies. So those are plug-in modules like any other module you can plug into this mainframe. And inside the mainframe there is of course a transformer with individual output voltages. It's pre-regulated and adjusted and filtered and completely individual. So all the different voltages you get out, you can put these in parallel or series or whatever you want to do, because it's, completely individual. One of these is not working. And that is, of course, how it is when stuff arrives in my lab. So first, let's see what works and what and what is the failure here. I don't really expect any kind of kabooms or anything like that. It should power up more or less normal, but we should just see some stuff not working. So that is obviously the biggest difference I see here from the outside. That is, we are in voltage, and this one is not good. I turned down everything to 0. Oh, output is now on. Okay. Oi, 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 look at that. We get 13 volts of output. And what is that? This is the 5 volt output. And this one should be a fixed output, right? 5 volt. So this one is not working. And then what else can we say? Okay, here we got volts. So this one is variable and it responds correctly on the meter and on the output. So that one is good. Let's go to that one over here. Okay. So those two are good. And this one is simply just a 13 volts. That is interesting. So we go over here and see what is going on over here. Oh, 4.7. Why isn't that 5 volt? Ah, so there's another difference between the two models here. There's a little adjuster so we can change the voltage. How nice. Okay, and then let's check this voltage here. Oh dear. Clickety clickety. So no voltage out of this one. We got so many things going on here. And this one gives you the right voltage. But the meter is not working. So we got more or less all the possible combinations we can imagine in this unit, right? I mean, we got voltage regulation, we got readout problem, we got no voltage output, and we got a full output here. Okay, let's get started. So, to isolate the problems, this was my initial error report on the green unit. So the left power supply was not able to give any voltage at all, right? But now it works fine. All I did was to unplug it and put it in to the right slot. And now my variable, let's see if we get some variable output, but the meter is stuck. So here we go. We still get variable output. Like that. and I adjusted my 5 volt. So all that is fine. So I believe the power supplies, the internal power supplies in the mainframe in the right slot is okay. But we are missing a power supply on the left slot. So that I need to fix first before we can proceed fixing the plug-in modules. So we know we got some missing voltages on the left unit and the right unit. We got all the right voltages, and everything is written nice and fine on a label here. And I did, of course, monitor all the different voltages, and I find this AC voltage here, the high one is missing, but the low one is there on this one. All the other voltages, they're fine. So now I turned it off and I'm using my ohm meter, and I find this pin here is not connected. And I measure almost 0 ohms because it's an AC winding. And on these, between these three, this is a symmetric part, just like this, right? And here I measure almost 0 ohms between those 3 windings, revealing they are, of course, connected to the transformer. So there's a missing connection somewhere. Now I need to follow that track and see if it's a mechanical problem or if something is really burned. So that was real easy. I just followed the tracks. I added a little mark here, follow that track, it goes here, it's to that. And then I realized this cable here wasn't really pushed all the way into the socket. So I pushed it all the way in and wiggled it a little bit, and now I got almost 0 ohms here. So let's see if it still works. But don't you just like the service friendliness of this unit? Look, we can access both of the circuit boards from both sides. This is how you want to design stuff. Super service friendly. I mean, you'll find a lot of units that is not like this. So we are back in business. One problem down. That was so fast. Okay, so now we got both of the voltages up and running, and the meter here is not working. So where are we going to look for that solution? As you can see here, it's just completely stuck, and it doesn't matter if I go to the voltage or the current mode, it's still the same. So I think I have an idea already where to look. It must be in the display drive, display handling kind of thing, right? See, and it's not responding to anything at all. It's supposed to go 0 if there's nothing loaded on it. Let's just go straight into the power supply. And again, it is just a new level of service friendliness. You can, of course, access everything from both sides. We can see somebody's been poking around here, but all this, I believe, is more or less repaired. However, I'm not super happy about the isolation distances, if you can see here, right? But anyway, that is some of the, there's a little rectifier and a capacitor and something like that has been bothering a previous owner. And I actually found all the manuals and schematics and everything about this unit in a little envelope that came together with this unit. So here is the power supply schematic, and this is really not that super interesting for me today because it's very conventional and it really works. So why would I bother with the power supply? Only to see, here is the voltage or current selector, and on the next page we get the component placement, blah 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 blah, not interesting. Here is the interesting stuff, because this is what is not working. And as you can see here, we got the 3 7 segments. They are multiplexed. So there's a BCD to 7 segment decoder driver, and then the display select. And it's all handled by this voltmeter chip here, the CA3162. And since all digits show exactly the same number, I feel this is probably the problem. It's not multiplexing, it's not running as it should be, because probably nothing goes on here and nothing goes on here. Everything is selected at the same time and then nothing goes on. I think I'll take an oscilloscope and prove this. And I think due to those series resistors and the current capability of everything here, this is just maybe the reason that we can't see any dim difference from a non-working display to the other one that is actually working. I figured out a lot of cool things I want to show you. So what I've done is I shorted the 2 grounds between the 2 power supply systems because they're completely individual. So of course I can just short the 2 main capacitors here with a little wire you can see down there, right? So that means now I can measure and compare what is going on between them. So if I dial down all voltages on both of the outputs, okay? And let's measure the ground here is of course 0. But on the other one that is behaving weird, I have a positive voltage. And of course between those two it's the same, because the difference between these two is the output voltage. So, I mean, there's something going on in this that is not right. And I also figured out all those parts. They're warmer and they're colder in the one that works. And then I took my little thermal camera. And what do you know? Let's compare the 2 halves. See? Very warm to the right and very nice and cold to the left. And here's the chip, 70 Celsius to the right. And see, 40 Celsius to the left. That is to blame for all the power supply parts that is warmer, because it just uses a lot of power. So this will be hotter. So here is a part called the 4053. That one must be burned, right? And my schematic is not exactly the right version. So that is of course also a problem. So once again, the thermal camera is definitely a super cheater in finding the errors. When I change ICs like this, so this is the 4053 that I changed, I of course add a socket, because if it blew up once, it might as well do it again next time somebody do something bad to this unit. So I mean, it's the same trouble, isn't it? And as you can see, it is working. So it was the reference voltages and the whole offset pull between the 2 power supplies, and that was caused by that IC. I'm quite happy about the situation right now, so now I can jump straight to the next one. I think it is so typical when people send in stuff for service, or when they service stuff and they forget about it or they get tired of it, they kind of lose the screws. I don't understand why, but I see this all the time. So now this power supply are already repaired. I don't have the self-tapping screws exactly the right type and style. But look what I got. I got one of those do-it-yourself plug-in modules. So this is a blank module, and this one had the original screws that I needed. So I stole the screws from this one, and then we'll have to solve this at a later point. But I think it's quite cool to see that you could buy these do-it-yourself kind of plug-in modules for this power supply mainframe system. And there's this little plug-in board here, and you can easily, I think it's explained here. Let's see the other side. No, it's not. I'm missing the manual for this one. But the idea is you get all the different voltages available here from the power supply module. It's actually that easy just to copy all the information from here, right? And then you can build whatever kind of little sexy module you need here and drill all the holes. And this is just a plastic plate, right? Quite easy to take this out, drill all the holes, put on the text and all that kind of stuff. And then you can have a purchase module and a DIY module, and then yeah, you have solved your test system need. So they really figured everything out. And I kind of like this. This is the first time I see this blank module in real life. So the only problem I can find with the red units, I make some little notes here so I know where we are and what's going on. And the 5-volt output is kind of blown up, so it delivers 13 volts. So that is what I need to remember. And all the other 3 units, they work perfectly fine. So that is all I have to worry about and see how that is. And another fun thing is this other module here. It's an older version. See, this is just called HM8040. And I think this model here fits my schematic. And this one is a very, very different. If we look at the top side, see how different that is. They're still using the same readout chips, and then the BCD to 7-segment driver is located correctly on the display board, like right there. It's a really funny layout just to fit those chips in there, isn't it? Oh, that is funny. So that big shadow switch here in the middle, that automatically turn on and off all the different outputs. In the later model we already shown, they're using 3 relays and a much simpler switch. I don't know what is best, but I kind of like the switches in this model here a lot better. There's a better clickety-clackety, better feeling. So I don't know exactly what to say about that, but and the 5-volt output here is definitely just this regulator here in the middle. I bet that one is just defect, and it's that simple, isn't it? Let's try and measure that. So okay, this schematic here is definitely the power supply I got here. And see, we also got the version down here, 8040, and no funky numbers or anything. And as you can see here on the schematic, we got a few serious design problems. For example, here is the positive and the negative output, and there's no diode that way. So that means if you have the power supplies in series and one is in current control or less current than the other one, and you short them or whatever happens, then you're going to get full reverse voltage of the other one into that one. They kind of solved it a little bit like here, but this is not the way you want to do it. You always want to just do it with a diode reverse here, and it's the same that happened to the 5-volt output. Look at that. No diodes at all. And you only need one diode from the output to the input, and then your problem is solved. Then you can't really blow this up when you do something wrong. But I will also recommend to have one diode here for higher voltage reverse in, or I will also have another diode from negative to positive. Now, it will be much more robust to everyday's little dumb things. And it's quite easy to see here that this is not the case. See, that will be the negative and positive for the 5 volt, and it goes directly to our blown up 5 volt regulator right there. And you see no diodes whatsoever. And of course there are no diodes because we don't have them on the schematic as well. So I will add all those diodes to this one. I should probably also do it on the previous one, but this is the one that I'm playing with right now, and all I want to do is change this regulator and add all the diodes. So this is what I really recommend you do in all those power supplies. Whatever kind of power supply you design or repair or whatever you do, really, you need to have this blocking diode to make it lab safe. And since this is a power supply that can only do a half an amp, 0.4, and this is why I use a 1 amp diode here in the reverse direction. And of course I also have a reverse diode on the 7805 pointing from its output to its input. So if you raise the output voltage, you're not going to blow the regulator as well. So I'm quite happy about this, and of course now the 5 volt works, but I realized another funny thing that I need to fix. It's really funny, the power supply really works, but look at that. What about those? This can't be good. Luckily I got another channel here that is working, and I got a really good schematic. So I think I want to replace those resistors that is obviously a little bit smoked. See, that will be the 2 burnt resistors, and those are the sense resistors. So the whole idea is all the output current goes through those 2 resistors. So how are you able to blow these up? Yeah, that is again, if you input something in reverse, then there is no protection, and then you have no control of your loop and all that. So I've added the diode, so this is not going to happen again. So here they are, a 1.87 and a 2R2. Okay, so I put in a 1.9, I think, and 2.2. It's not super important what you have, because you can calibrate everything here. And so here's how it's done. We got those different trimmers here. We got 3 trimmers. One is the milliamp range. The offset is only for 0, and then you have the volts individually. But if you play around with the milliamps, you also affect volts. So the trick is to put in the correct reading for milliamps first, and then go back to voltage. Let me show you how this is done. So at the moment I have 100 milliamps exactly, and the readout is a little bit wrong. Okay, so I stick in my little adjuster here into that trimmer. Come on, baby. And then we'll try and dial the current to exactly 100. And then you will see voltage is now wrong. So I try and take my voltmeter back. It's difficult to do with one hand. See, now it's not reading the correct volt. And then we take, of course, the first trimmer down here. And now we should be able to handle the voltage readout. Oh, I can't go all the way down. How annoying. And this is because my resistors, they're not exactly as I want. How annoying is this? But now I want to go back and see if my current is still correct. Let's see what happens here. And I have 100 milliamps, and this is right. Okay, so what I want to do is I want to repeat this, and I now changed one of the resistors. So this is what I did. I added a, I don't know if you can see this. Here you go. Those 2 resistors right there. It is dark as... See? I mounted them so it's easier for me to play around with them. So what else can I show you? I have the maximum current set up here. So if I crank up now the current, so this power supply should be able to do 400 milliamps, right? So let's try and do 500. And look what it says here. So there's a little lamp that goes on. So it's doing, oh, volts meter goes 0. And now we have a constant current mode of 447. And it is, if I measure right here, 440 something. So it's quite close, and I'm super happy about that. So that was real easy. I just changed one of the resistors. It turned out to be a little bit too low, so I changed it to another one that was a little bit higher. And let's go to the voltmeter. See, 11.1 digit. Yeah, whatever. That is the resolution. That is how it is, right? And then we go into the milliamps, and now I have changed my load to give it 200 milliamps, and now it's 200 here. So I'm quite happy about this whole unit. It's nice and accurate. And if I flip over to the left unit, it is of course spot on. I don't need to do anything because this one wasn't blown up. Anyway, I think we are done with the power supplies here, and we can call it a day. And thank you very much for watching. I hope you had a little bit of fun. Bye bye.